All right, hello. So here we have the dispersion and probability review package. So let's go through that real quick, okay? So question one, we want to find the range IQR and draw a box and whisker plot for each of these data sets. So first thing we could do, okay, is just find the range, right? The range is just your biggest number, your max, minus the minimum. So we've got 99 minus 12, that's just going to be 87, okay? Now, to find our IQR, we're going to need Q1 and Q3. Before we get to that, we have to find Q2, obviously, okay? So how do I find Q2? Well, we've got 7 numbers over here. So n is equal to 7, which is odd. We do n over 2, which is 7 over 2. We get 3.5. We round that up to the 4th position. 1, 2, 3, 4. Right here, that is my Q2. Okay, so Q2 is equal to 34. Now, in each half, right, on the left of my median, I have 3 numbers. On the right of my median, I have 3 numbers. So H is equal to 3. This is odd. So H is, H over 2 is 3 over 2, which is 1.5. We round that up to the second position in each half. So 1, 2, right here is Q1. 1, 2, right here is Q3. Okay, so we've got Q1, Q2, and Q3. So my IQR is going to be equal to Q3 minus Q1, which is 98 minus 14. We get 84. And now all that's left to do is to draw my box and whisker plot. So it's going to look something like this. Okay, you don't have to make it like exact or to scale here. Okay, we've got my min, which is 12. You got Q1, Q2, Q3, and your max. Your max is 99. Maybe I'll write it underneath it so it's easier. Okay, your min is 12, Q1 is 14, Q2 is 34, and Q3 is 98. Okay, that's all you gotta do for question 1A. Let me scooch this down a little bit, and I'll move this up. Okay, so B. We've got 1, 2, 3, 4, 5, 6 numbers. So first things first, just find the range. Okay, range is just going to be 15 minus 1, which is 14. Right? Now we move on to finding our Q2. So we have n is 6, which is even. So n over 2 and n over 2 plus 1 now, right? We've got 6 over 2, which is the third position. And here we've got 3 plus 1, which is the fourth position. So it's between my third and my fourth positions. It's going to be right here. That's where my Q2 is going to go. So Q2 is sandwiched between these two numbers in the third and fourth positions. So Q2 is the average of those two numbers, right? We take those two numbers up, add them up, divide it by 2. That's 11 divided by 2, which is 5.5. Okay? So Q2 is 5.5. Now, on each half, here you've got 3 numbers. On the other side, we've also got 3 numbers. H is equal to 3 again, which is odd. So H over 2 is 3 over 2, which is 1.5. We round that up to the second position in each half. So this is Q1. This is Q3. Okay? So to find my IQR, we take 10 minus 3. It's just going to be 7. All right? And box and whisker plot. Okay, you've got your min, Q1, Q2, Q3, and your max over here. Your min is 1, your max is 15. Q1 we said was 7, Q2 was 5.5, and this is, no, that's my bad. Q1 is 3. Q1 is 3, and Q3 is 10. There you go. I accidentally wrote the IQR. Okay, 1, 3, 5.5, 10, and 15. Okay. Next, we got question C. So here we got 1, 2, 3, 4, 5, 6, 7, 8 numbers. All right. So to find your range, take the biggest number minus your smallest number. We got 84 minus 27. Okay. So that's just going to be equal to 57. All right. To find your Q2, you do n equals, we said that was 8, which is even. Right, so we have to do n over 2 and n over 2 plus 1. N over 2 is 8 divided by 2, which is the fourth position. Here we've got 4 plus 1, which is the 5th position. So 1, 2, 3, 4. Between 4 and 5 is Q2. We want to find the average of the two numbers that are sandwiching my Q2. So Q2 is equal to 52 plus 56 divided by 2. That's just going to be equal to 54. Okay. Now on each half I have 4 numbers. So H is equal to 4, which is even. All right. So we have to do H over 2 and H over 2 plus 1. 4 divided by 2 is the second position. And here we have 2 plus 1 is the third position. So right here, between my second and third position is Q1. Between my second and third position right here is Q3. So they're also between two numbers. We're going to find the average of those two numbers. So Q1 is equal to 33 plus 34 divided by 2, right? We add them up, divided by 2, we get 33.5. Q3 is equal to 67 plus 77 divided by 2, and that's going to be equal to 72. Okay, so my IQR is equal to 72. Let me go right on the side here. So I have more room. IQR is equal to 72 minus 33.5, and that's going to be 38.5. And you could draw your box and whisker plot here like this. Okay, we've got your min, Q1, Q2, Q3, max. Your min is 27. Your max is 84. Q1 is 33.5. Q2 is 54. Q3 is 72. Okay. Scooch this down a little bit. Okay. Now, D. Let's start with a range as we did before. We've got 96 minus 44. That's just going to be equal to 52. All right. We have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is equal to 9, which is odd. So we do n over 2 is 9 over 2, which is 4.5. You round that up to the 5th position. So 1, 2, 3, 4, 5. Right here, that is my Q2. It's 57. Okay. On each side, we've got 4 numbers. So in each half, H is equal to 4, which is even. So we got to do H over 2 and H over 2 plus 1. So equals and equals. H over 2 is 4 over 2, which is the second position. Oops. Let me scroll down a little bit. There you go. Okay. Second position. And H over 2 plus 1 is the 2 plus 1, which is the third position. Okay, so right here and right there, we've got my Q1 and Q3. Okay, so once again, they're between two numbers. So Q1 and Q3, we got to find the average of the two numbers that are sandwiching my Q1 and Q3. So 45 plus 49 divided by 2, that's going to be 47. And here we've got 68 plus 79, divide that by 2, that's going to be 73.5. Okay, so my IQR is going to be 73.5 minus 47. That's just going to be 26.5. And now you can draw your box and whisker plot here. You've got your min, Q1, Q2, Q3, max. We got 44, 96. Here we've got 47, 57, and 73.5. Okay. Next. Okay. So we've got 6 out of 8 missing numbers, and we want to figure out what the two numbers are. We know that the average of the two missing numbers is 39.5 centimeters. Okay. So let's see what we've got to work with, right? The first thing I want to look at is my min and max, right? We always know those are the two numbers that are guaranteed to be in my data, okay? Q1, Q2, and Q3, they might be there, not guaranteed though, okay? And the easiest ones are always your min and max. They're the biggest and smallest. Are they in my data? Yes, they are, right here and right here. So we can cross those out and place them in my boxes over here, okay? So 0 and 140. Next, let's look for Q2. So how many numbers do I have? It says we have 6 out of 8, right? So n is equal to 8, which is even. So n over 2 and n over 2 plus 1. We've got 8 over 2, which is 4, is the fourth position. And here we've got 4 plus 1 is the fifth position, okay? So we go down here. Between my fourth and fifth positions, 1, 2, 3, 4, right here is where my Q2 is going to go, and I know it's 58. Okay. Next, because this is between two numbers, it doesn't really tell us it's a number in my data. Okay. So let's just move on after that. Okay. We don't really know what it is. It's just between two numbers. So H, how many numbers do I have in each half? On this side, we've got 4 numbers. On this side, we've also got 4 numbers. Okay. So we've got H is equal to 4, which is even, okay? 4 is even. So we have to do H over 2 and H over 2 plus 1. We've got 4 over 2, which is the second position. And here we have 2 plus 1, which is the third position. So between my second and third, 1, 2, 3, right here is my Q1, which is 20. And here we've got Q3, which is 114. Okay? And once again, they're between two numbers. Does not really tell us anything about the numbers next to them yet. Okay? All we know is that they're between two numbers, which is not the most helpful thing to have. So at this point, we've exhausted all of the information that we could get from the box and whisker plot. So at this point, we're just going to look at the numbers up here and start plugging them into these boxes and see what works and what doesn't. So we've got 17, then 60, then 112, then 116. Okay, so 17 and then 60. Okay, well, I know 17 works because 17 is bigger than 0, but less than 20, right? We're going in increasing order here. So 17 fits right there. That's perfect. 60, sure, it's bigger than 20 and bigger than 17, but it's smaller than 58, which is Q2, and Q2 58 goes right here. So 60 makes absolutely no sense. So it's going to have to move up here at least, okay? And I know there's 112 and 116, so those fit nicely. So here are my two missing numbers. Here I have x1 and here I have x2, okay? Now I have these two numbers which are sandwiching my quartile. Well, that's great because then I know 17 plus x1 divided by 2 is equal to 20. And here, same idea. I have 60 plus x2 divided by 2 is equal to 58. Okay? So, what can I do with that? Let me round the next page because I ran out of space. Or actually, right here. I'll write right here in this box. Okay? We've got 17 plus x1 divided by 2 is equal to 20. So we cross multiply, we get 17 plus x1 is equal to 2 times 20. So 17 plus x1 is equal to 40. x1 is equal to 40 minus 17, which is 23. So x1 is 23. Okay, we've got my first missing number. My second missing number, to find that, we have 60 plus x2 divided by 2 is equal to 58. Same idea, we cross multiply, we get 60 plus x2 is equal to 116. So x2 is equal to 116 minus 60, right? We brought that 60 to the other side. Same idea here, okay? And so x2 is equal to 56, okay? Now, yeah, so here we have 56. This is 56. Another way you could have solved this, okay, for the second missing number is, remember, they gave us up here, the average of the two missing numbers is 39.5, okay? So the average of the two missing values, so x1 plus x2 divided by 2 is 39.5. So once you've found your x1, you didn't have to find, Q2, not Q2, X2 using this over here on the right, what you could have done is said, oh yeah, X1 is 23. So 23 plus X2 divided by 2 is 39.5. Same idea, we cross multiply here, okay? And we'll get 23 plus X2 is equal to, oh, there's no room here. Okay, let me write it down here. 23 plus X2 is equal to 2 times 39.5, which is 79. So X2 is equal to 79 minus 23, which is 56, which is the same answer we got down here, okay? So 2 different ways, either way works in this question, okay? But usually if they tell you this, I would recommend using this average here, okay? It's usually a little easier. Next, B, we have 5 out of 6 numbers. We want to find the missing value. So once again, let's start with my min and my max. We know it's 12 and 33. They're up here. Okay, they're guaranteed in my data. So 12 and 33. We put them in these boxes here. Okay. Next, Q2. So how many numbers did I have? The question tells me there's 6 numbers. Okay, so n is equal to 6, which is even n over 2 and n over 2 plus 1. This is 6 over 2, which is 3, third position. This is 3 plus 1 is the 4th position. So between my 3rd and 4th positions, right here is Q2, which is 20, okay? So now on my left here, I've got 3 numbers. On the right, I've got 3 numbers. I know H is equal to 3, which is odd. So I do H over 2, which is 3 over 2, gives you 1.5. You round it up to the 2nd position in each half. So 1, 2, right here, this is Q1, 1, 2, right here, this is Q3, okay? So Q1 we know is 18, Q3 I know is 28. And because they're pointing straight into a box, then I could just put 18 here and 28 here. They're not between 2 numbers, they are a number in my data, okay? 18 and 28, were they in my data up here? Yeah, they are. So 18 and 28, we cross those out. All that's left to put now is 22. So we scroll back down, we've got 2 options, we've got here and here. But because this list is going in increasing order, 22 has to go right there. And so here's our x. These are the 2 numbers, x and 22. They're sandwiching my Q2. So I know x plus 22 divided by 2 is going to be Q2, which is 20. So x plus 22 is equal to 2 times 20, which is 40. So we bring this 22 to the other side. X is equal to 40 minus 22, which is 18. Okay, so x is equal to 18. Last question over here in this section, we've got 6 out of 9 numbers. Now we're missing 3 numbers, okay? And the range of the data is 18, the IQR is 7, and one of the missing values is equal to the Q3, and the average of the 2 missing values, which are not the minimum, is 17, which kind of already gives away that one of the missing values is the minimum, okay? So first things first, let's try to use this piece of information to help us out. The range of the data is 18, which means the distance between the biggest and smallest numbers in my data is 18. Well, I know my maxes is 23, so 18 numbers below that, how do I find that? I know, okay, so you know IQR, what am I writing? Range is 18, okay? We know range is 18. So how do I find a number that's 18 numbers smaller than 23? All I do is 23 minus 18, and that gives you 5. And because of that, I know that is my minimum. Because range is 18 and this is my max, then this is my min, 5. Okay? So there should be a 5 over here. So that's the first missing number. Okay? 5. So I can put that right here. Okay? Because the distance between my biggest and smallest number is 18, then I can just do 23 minus 18 gives you 5. This is the smallest number. Minimum. Okay. So we've used this information. Check. The IQR is 7. What is IQR? That's the distance between my Q3 and Q1. So if there's 7 numbers between 12, which is Q1, and my Q3, right? Because IQR is 7, then to find Q3, all I have to do is take my Q1 and add 7 to it. I want to find the number that's 7 numbers bigger than Q1, which is 19. So 19 goes right here. Okay. So we've got 19 is my Q3. So we know as well that one of the missing values is equal to Q3. So if I know what Q3 is, then one of my missing values, which is equal to Q3, has to be 19 as well. So let's say x1 is equal to 5, x2 is 19. Okay, we have 2 missing numbers already. I just have 1 left. So let's look at this last piece of information. It says the average of the 2 missing values, which are not the minimum, is 17. So we still have one of the missing values, right? And it's saying the average of the 2 missing values, which are not the minimum, is 17. So that's talking about these 2 numbers over here, okay? So the average of 2 numbers, right? We just take x2 plus x3 divided by 2 is equal to 17. But we know what x2 is. It's 19. So 19 plus x3 divided by 2 is 17. 19 plus x3 is equal to 2 times 17. Let me scroll down. Okay, so 19 plus x3 is equal to 34. x3 is equal to 34 minus 19, and that's just going to be equal to 15. So we've got x1 is 5, x2 is 19, x3 is 15. That's your final answer, okay? And you don't have to fill out any of these boxes. The question was just asking you to find the 3 missing values, and we found them, okay? Once you find all 3, just move on to the next question. You don't have to fill out these boxes, okay? All right, simple probability. Are the following compatible or incompatible events? Rolling a number below 5 and rolling a number above 3, I mean. So remember, compatible means these 2 things, these 2 events, rolling a number below 5 and the event of rolling a number above 3. Compatible means they can happen at the same time. It's possible for these to happen simultaneously, okay? Incompatible is just the opposite. They can't happen at the same time. Is there a number that's below 5 and above 3? Yeah. Number 4, okay? And because number 4 is below 5 and above 3, then it is possible to roll a 4. So these are compatible, okay? Next, rolling an even number and rolling a number below 2, are these compatible or incompatible? Well, the only number that's below 2 is 1, and 1 is odd, which is not even. So if you rolled a number below 2, you rolled 1, which is odd, which means you cannot roll an even number. So these are incompatible, okay? There's no way you roll a number that's below 2 that is an even number. Okay, next. Are the following examples of theoretical or experimental probability? So remember, experimental means we've done the experiment before and we're just looking back at the data and we're going to find an experimental probability. Theoretical is we haven't done the experiment. We're just kind of looking at the number of ways my event can happen divided by the total possible outcomes, okay? And we haven't done the experiment at all. We're just kind of just using math, okay? So A, Mr. Hum takes note of when he arrives at LHA before Mr. Pagano. After 20 days, he arrived first 14 times. I don't even have to read the rest of this question. I know I've tried the experiment already, right? After 20 days, I arrived first 14 times. I've done this 14 times, or 20 times, and the event happened 14 times, okay? This is obviously going to be experimental, okay? Next, Melina has 6 highlighters, 2 are blue, 3 are yellow, and 1 is pink. She concludes that there is a 0.5 chance, because there's 3 out of 6, right, yellow highlighters. So she says there's a 0.5 chance of randomly selecting a yellow highlighter, okay, 3 out of 6. So, has she started pulling highlighters from a pencil case yet? Has anyone in this watching this video pulled highlighters from a pencil case? No. She's just saying there's 3 highlighters that are yellow and that she has 6 total highlighters, okay? So this is theoretical, okay? Theoretical. Next, Zachary flips a coin 9 times, it lands on heads 7 times. He calculates that there's a 77.8% chance of landing heads. Well, he flipped the coin 9 times. He's done the experiment 9 times. This is experimental, okay? Moving right along, a bag contains 12 green marbles, 4 blue marbles, and 4 red marbles. What is the probability of randomly selecting a red marble from the bag? How many red marbles do I have? 4. How many total marbles do I have? 12 plus 4 plus 4. So 12 plus 8 is 20. 4 over 20 is the same thing as 1 over 5. That is 0.2, or 20% chance. Okay? Question 4. What is the probability of rolling a number less than 3 on a standard 6-sided die? So let's look at this. Okay, my sample space, I have 1, 2, 3, 4, 5, 6. Okay, which numbers are less than 3? Well, it's these two right here, right? Is 3 less than 3? No, 3 is equal to 3. It's not less than 3. So it's only these two, number 1 and number 2. So you've got 2 possibilities out of a list of 6 outcomes. So 2 over 6, that's the same thing as 1 over 3, which is 0.3333, blah, blah, okay? Or 33.33%. Okay? Question 5. In a bag of 5 red marbles and 3 blue marbles, what is the probability of selecting a green marble? How many green marbles do I have? 0. How many total marbles do I have? 8. 0 divided by 8 is 0, or 0%. Okay? There's no way you can pull a green marble out of a bag with just 5 red marbles and 3 blue marbles. Pulling a red marble is impossible. Okay? Next, what is the probability of not rolling a number greater than 2 on a standard 6-sided die? So let's look at my sample space. We've got 1, 2, 3, 4, 5, 6. Okay, what are my probabilities of rolling a number greater than 2? There's 4 possibilities, right? So 4 on 6, which is 0.6666, okay? 67, let's say, we'll round it up, okay? Or 66.67%. But that's the probability of rolling a number greater than 2, right? But rolling a number that's, well, not rolling a number greater than 2 and rolling a number greater than 2 are complementary events. So to find out the probability of not rolling a number greater than 2, we'll just do 100 minus 66.67%, which gives you 33.33%. Okay? Next, what is the probability of rolling an even number on a 6-sided die? Okay, so we have my possibility here. 1, 2, 3, 4, 5, 6. How many of these are even? 1, 2, 3. We've got 3. And how many possibilities are there in my list of possibilities? I said possibilities a few times. How many things do I have in my sample space, right? We have 6 different outcomes. So 3 on 6, which is the same thing as 1 on 2, which is 0.5 or 50%. Okay? All right, counting arrangements. So how many different ways can you arrange 8 shirts on a rack? So we've got 1, 2, 3, 4, 5, 6, 7, 8 different places, right? 8 shirts. How many options do I have for my first shirt? I want to hang a shirt in the first position. How many options do I have? Well, I still have 8 shirts, so I can put 8 different shirts here, okay? Now, after I've placed one of the shirts, how many shirts do I have left to place? I have 7. Okay, I've placed 2 shirts. How many shirts do I have left to place? 6. I've placed 3 shirts. How many shirts do I have left to place? 5, and 4, then 3, then 2, then 1 left. We just multiply all of these up, okay? And that's gonna give me 40,320, okay? You could have also written 8 factorial, okay? 8 exclamation mark. Okay, a password consists of 2 letters followed by 3 digits. Once a letter and a digit has been used, it cannot be used again. Okay, so we've got 2 letters and 3 digits. Okay, how many letters are there? There's 26. So my first thing, let me write this here. Letter, number, or digit. Okay, digit, digit, digit. Okay, so my first thing here, I've got how many letters to choose from? We still have 26 letters, right? There's 26 total letters. Okay, I've used 1 letter. Now my second letter, I cannot use that same letter that I used for my first position. So there's only 25 letters left to choose from. Okay. Now, my first digit. How many digits are there? So this is really important. Okay. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's a 10th digit. It's 0. Okay. So there's 10 digits to choose from. All right. It might look like it's 9, but don't forget 0. Okay. There's 10 digits. So there's 10 options here. Once I use this digit, there's 9 left. Then there's 8 left. We slap in a bunch of multiplication signs between them. How much does that give me? It should give me 468,000. Okay. What is the probability that I guess it right? There's only one right answer, right? There's only one right password. You can't have two different passwords. So there's one right answer out of how many? 468,000. Okay. And that's going to give you 0.00002136. Okay. Maybe there's another 0. Yeah, there's 5 zeros here. Okay. Next, a competition has 18 participants. How many different ways can we distribute the gold, silver, and bronze medals? So basically like first, second, third place, okay? So gold medal, we have 18 participants. How many different people can win the first place, right? So technically everyone has a chance of winning. So there's 18 options. Okay, someone's won gold already, okay? And you can't win gold, silver, and bronze, okay? Once you've gone to medal, you can't win another one. So how many options are left for silver? Well, one person already has gold, so there's 17 options left. Now gold and silver have been given out. There's only 16 people left who can win bronze. We multiply those together. You should get 4,896, okay? Next, the last question is a race has 9 horses, okay? And I want to know how many different ways they can finish. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. In my first place, how many different horses can win first place? Well, there's 9 horses. They all have a possible chance of winning the first place. So I have 9 options, okay? Now, a horse has won the first place. How many can win the second place? 8. Okay, we've got the first and second. How many horses are left to choose from for my third place? 7, 6, 5, 4, 3, 2. Then there's 1 left. Okay, we multiply all these together. You could have also written this as 9 factorial. Okay, and that's going to give you 362,880. Okay. Now, question 5. A team has 29 members. How many ways can they choose, or can the captain and vice captain be chosen? So there's the captain and vice captain. How many options do I have for my captain? 29. Okay, you can't be captain and vice captain. So once you're captain, you can't be vice captain. How many options are left for vice captain? Well, someone's already captain, so there's only 28 people left to choose from. Okay, and that's going to be 812. All right, 29 times 28 is 812. Question 6. How many different car number plates are possible that start with 3 letters that are then followed by 3 digits? So we've got 3 letters, then 3 digits. Remember, for number plates for cars, for example, you might have one that looks like this, right? Like 1, 2, 3, okay, or 1, 2, 2, okay. Letters and numbers can repeat, okay. So we have 3 letters. We start with 3 letters followed by 3 digits, okay. So 26 options, 26 options, 26 options. Digits, we've got 10 options, 10 options, 10 options. Slap in a bunch of multiplication signs between them, okay. How much does that give me? It should give you, let's try that actually, 26, 26, 10, 10, 10. Okay, 17,576,000 different possible number plates that just start with 3 and then end with 3 letters and then end with 3 digits, okay? How many of these number plates begin with ABC? So, how many options do I have for my first letter? Well, I know it has to start with A. So there's only one option. It has to be A. Same thing here. It has to be B. And here, it has to be C. There's no other option. Okay? But there's no restriction on my digits. So I could have any digits. 10, 10, 10. That's going to give you 1,000. Okay? 1,000 different plates start with A, B, C. Now, if a play is chosen at random, what is the probability that it begins with ABC? So how many different plates do I have with that start with ABC? 1,000 out of how many? 17,576,000 different number plates, okay? Which gives you 0.0000569, okay? That's the probability. Okay, how many of these license plates contain no repeated letters and no repeated digits? So that's almost the same question as question A, okay? So 1, 2, 3, 1, 2, 3, except now we have 26 for the first one, first letter. Now we can't repeat the letters. So here we've only got 25 letters left to choose from, and then 24. Here I've got 10 digits to choose from. Now I've used this one. There's only 9 left, then 8 options left. Put in a bunch of multiplication signs between them, and that's going to give us how much? 26 times 25 times 24 times, 10 times 9 times 8. That's going to be 11,232,000. Okay? Let me write that a little bit better. Like this. Okay? All right. So, next question. Kai has 12 shirts, 6 sweaters, 9 pairs of pants, 3 hats, and 2 pairs of shoes. So, shirts, sweaters, pants, hats, and shoes. Okay? How many options does he have for shirts? 12. How many options does he have for sweaters? 6. Pairs of pants? 9. Hats? 3. Pairs of shoes? 2. Bunch of multiplication signs between them. How much does that give you? 3,888. Okay? Make sure you're following along and trying these on your calculator as well. Okay, don't just watch me do it. All right? All right, so the last section is geometric probability. Let me get a sip of water for a sec, actually. Hold on a sec. Okay, so let's find the area of the shaded circle to start with, all right? So the formula for a circle, the area of a circle is pi times r squared. The radius is the distance from the center to the side of the circle, which is 1 centimeter. So pi times 1 squared, 1 times 1, which is 1 squared, is just 1, right? So we're left with pi centimeters squared. Okay, we're going to say pi is like 3.14. Okay, in case you don't have a pi symbol on your calculator, we'll say it's 3.14 centimeters squared. Okay, now the area of the trapezoid, okay, the formula for that is big base plus small base times height divided by 2. Big base is 6, small base is 4. Okay, what's the height? We know this is 1, so this is also 1. So in total, okay, in total over here, the height is 2. So we have to do 2 over 2. So that gives me 10 times 2 divided by 2, which is 20 over 2. It's 10 centimeters squared. So to find the probability of landing in my shaded region, it's just going to be the area that's shaded. Oh my goodness, what happened here? Okay, my apologies. I don't know what just happened. Okay, we have area of the shaded region is 3.14 divided by the total area is 10, which is 0.314. Okay, or you can say that is 31.4%. Okay. Next question. We've got a trapezoid inside a rectangle, and then we've got these 2 triangles here. Okay, so what we can do instead of finding the area of the triangles is just find the probability of landing in this trapezoid right here, and then taking 100 minus that probability, because landing in here and landing here are complementary events. Okay, so because this is 12 and this is 4 and that's 4, then 12 minus 4 is 8. No, that's not right. Is 12 minus 8, which is 4. So this is 4 as well. Okay, I'll keep that there actually. I don't know why this keeps jumping up. Okay, so we know this small base right here is 4 and the big base is 12. All right, so let's find the area of the trapezoid here. We've got big base is 12 plus 4 times height is 2. Divide that by 2. We get that is 16 meters squared. Now the area of the rectangle is just length times width. So 12 times 2 is 24 meters squared. So the probability of landing in the trapezoid is 16 over 24, okay, which is going to be, what is that? 66.66%, 67%, okay? Or let me actually write that first as a decimal. 0.6667 or 66.67%. And so because the 66.67% of landing in here, okay, then we just have to do 100 minus 66.67, which is 33.33% chance of landing in those triangles, all right? If you really wanted to, okay, you could have found the area of the triangles as well. So you could have done base times height divided by 2. So area of, let's say, one triangle here, okay, is 4 times 2 divided by 2, which is 4. Because we know there's 2 triangles, then total shaded area. Oops, I've been writing off the screen here. Okay, let me scroll down. Okay, so what I did was I took the triangle. I said the area of the triangle is 4 times 2 divided by 2 is 4. So the total shaded area, okay, is equal to 4 plus 4 because there's 2 triangles. So we have 8, okay? And we know the area of the rectangle is 24. We found that up here. So area of the shaded region is 8 divided by total area is 24. We get back to 33.33%, okay, which is what we got right here. So both ways work, okay, whichever comes to mind during the test or your evaluation, you can use that. Both ways give you the same answer, okay? Next question. So we've got this funny looking shape here, okay? So what do we know? We know that this diameter of the circle is 4. So if this is 4, right? If that's 4 meters, then this height right here, this diameter, is also 4 meters. And if we know that's 4 meters, then this is 4 meters. And if that's 4 meters, then 9 minus 4 is 5. That tells me that this height right here is 5 meters, okay? And this length right here, well, if I know this is 4 and that's 4, then 4 plus 4 is 8 meters, okay? So that's going to be kind of helpful for the rest of the question, all right? So let's find the area of the circle first, okay? So that's just going to be what? Pi r squared, right? Remember the area of a circle is pi r squared. So what is r in this case? R is just going to be half of the diameter, which is 2. So r is 4 over 2, which is 2. So we've got pi times 2 squared, okay? Pi times 2 squared is just 4 times pi. And let's say we don't have pi on our calculator, so we use 3.14 times 4. We get 12.56, okay, meters squared. Now, the area of this triangle down here, right, is going to be what? Base times height divided by 2. So base is 8 times height is 5 divided by 2. That's going to be 20 meters squared. Now, this weird looking shape, okay, this outer shape, L looking thing, we can split that into 2 parts, okay? We've got this square on top, and we've got a rectangle underneath it, okay? So, on top here, remember we said that was 4? Oh, I still have it there, okay? The height of that is 4, okay? So, oops, I erased too much. All right, so the top part, the square, okay, we've got 4 times 4, which is 16. And this lower section over here, okay, the lower rectangle, is length times width. Length is 8 times width is 5. 8 times 5 is equal to 40. So the total area of this L shape is 16 plus 40, which is 56. That's my total area, okay? Total area is 56 meters squared. So to find the shaded area, okay? Well, actually, let's not find the shaded area. Let's find the probability of landing in the white region, and then we'll do 100 minus that. So what's the probability of landing in a circle or the triangle in one of these white areas? Okay, so first we have to find the total white area. So we'll do 20 plus 12.56, which is 32.56. Right, this is total white or unshaded area. So the probability of landing in the unshaded area is 32.56 divided by 56. 32.56 divided by 56 is 0.58. You will put 1 4 as well, okay? And so the probability of landing, let me write this, 58.14%. The probability of landing in the shaded area is 100 minus 58. Let me scroll down. 58.14, which is 41.86%. Okay? And now we have, this should go down here to the next page. Okay. So here we've got a rectangle and we've got a triangle inside of it that's shaded in. So we know the height of this triangle is going to be 2 centimeters, right? It's just half of this 4 centimeter thing. So the area of the triangle is base times height divided by 2. What is the base? Well, this has got to be 6, right? 6, because half of it is 3. So base is 6, height is 2 divided by 2 is going to be 6. Okay, 6 centimeters squared. The area of the rectangle is length times width. Okay, so length is 6, width is 4, that is 24. So the shaded area is 6 divided by total area is 24. That's 1 on 4, or 0.25, or 25%. Okay? And now we've got a triangle inside of a circle. So same deal as before. Let's find the probability of landing in the triangle, and then we'll do 100 minus that probability. Okay, so the area of the triangle is going to be, well, we know the base is 4. Okay, so 4. We know the height is 3 divided by 2. That's going to be 6 centimeter squared. The area of the circle is pi r squared. Okay, what is the radius of my circle? I know the diameter is 5, so if diameter is 5, then the radius is half of that, is going to be 2.5. Okay, so we've got pi times 2.5 squared, okay, or 3.14 times 2.5 squared, which is going to be 19.625 centimeters squared. So the probability of landing in the triangle, which is the unshaded region, okay, is 6 divided by the total area, which is the area of the circle, which is 19.625. So 6 divided by 19.625 is 30.57. Okay. And so, percent. Let me write that as a decimal first. I keep jumping straight to percentages. Okay, 0.3057 or 30.57%. Okay. And now the probability of landing in the shaded region, because landing in here and landing out here are complementary events, I could just do 100 minus 30.57%, which is 69.43%. Okay. And last but not least here, we've got this hexagon with a circle inside. Okay. So the probability of landing in the shaded area, what we're going to do is we're going to find the probability of landing in the circle, and then we'll do 100 minus that probability. Okay, same as we've been doing in the last couple of questions. So the area of, let's start with the circle, okay, is pi r squared, right? My radius is 20, so we've got 3.14 times 20 squared, okay? So 3.14 times 20 squared is going to be 1256 meters squared. Now, the area of this hexagon, okay, remember the formula is the number of sides times the side length times the apothem divided by 2. So, how many sides do I have? We've got 6 sides is a hexagon. My side length is 25, and my apothem is the length from the center to the center of one of my sides, okay? From the middle of one of my sides to the center, so it's 20, and we're going to divide all that by 2. What does that give me? 6 times 25 times 20 divided by 2 is 1,500 meters squared. So the probability of landing in the unshaded region in the circle is 1256 divided by 1,500, okay? And that's 83.73%. And so the probability of landing in the shaded region is 100 minus 83.73, which is 16.27%. Okay? And that's gonna do it for this review package. All right, so if you have any questions, just leave it in the comments. All right, don't forget to like, comment, and subscribe. I guess I don't know how to do these outros, but yeah, have a good day. Bye.